All right, welcome back and thanks for tuning in again. So today, I want to get back to working on this 45 kilowatt Perkins gen set. If you haven't watched any of the previous videos regarding this machine, check out the link in the description for the playlist, and I'll try to leave like a card or something for that as well. But it'll give you a better idea of what all's been done to it so far and what we still have left to do. So what I want to do today is get the control upgrade finished. I've already started it. I've already done some wiring on it, mounted the control panel. We'll get into that in a second. But I want to get the wiring finished up, and I want to get the control panel programmed and get initial no-load testing done. Once we do that, we'll be ready to move on to the final commissioning, so to speak, where we'll give it a 4-hour load test and make sure it's really solid and ready to go. So let's get started. Let's take a walk around and have a look at what I've done since the last video. So the engine wiring harness is all new, and it's actually complete at this point. So all the old stuff was gutted. Everything here is new. The alternator wiring. We got the junction here at the starter. We got two automatic circuit breakers here. We'll go into those, what their function is in a little bit. Harness comes up to the control panel, comes back out, and this little box over here, this used to contain a battery maintainer, but I've repurposed it, got rid of the battery maintainer, and we're utilizing this as the enclosure for the electronic governor and the two solenoids here. One solenoid is for the starter, the other one is for the intake heater or the thermostat device. I'll show you that in a second as well. This has all been wired up and trimmed out. I just have to make up a couple labels for the solenoids, a couple of the main wires. Pretty much everything in here is self-explanatory though. Over on the engine, I went and replaced all of these freeze plugs. All these new brass freeze plugs, there's 9 of them in total. And that's, well, the reason I did that is because 2 or 3 of them, I forget which ones now, you could see the paint bubbling around underneath of them and starting to lift off. So there were some really tiny pinhole leaks starting. So I ended up pulling out all of them and replacing them with these nice brass freeze plugs. Again, the engine wiring harness here is all new. We got our oil pressure sender, a mechanical gauge as well. I always like to have a mechanical gauge there for pressure, oil pressure, and water temperature. Here's the water temperature gauge. Just as another point of reference, not that I doubt the accuracy of the electronic gauges on the panel, but again, it's always nice to have 2 points of reference. Governor, we saw that in the previous video. There's the actuator wiring harness. It snakes around behind the injection pump, meets up with this harness. The water temperature sender is hidden way up here. See that right down there, right in front of the cylinder head. Originally the temp sender was right here where this pipe plug is, there, but the length of that sender is not sufficient enough to reach down into the coolant jacket, so I had to relocate it up front there. Yeah, this all came out pretty well. I'm pleased with it. And of course made a battery rack here. So we got 2 group 31 batteries. They are in parallel. This is a 12 volt system. So we got 2 in parallel there. New battery cables which run along the frame here and over to the starter. So really the only thing that needs to be done wiring wise is the control panel here. It's just a big loom of wire in here yet. But we got our Basler DGC 2020 control panel. We got a Basler AVC 63-4 voltage regulator, wiring harness. Got 3 control relays. I'm going to have one for preheat, one for crank, one for run. We've got a small fuse panel here, distribution block. I decided to go with automotive type fuses because I feel like whoever buys this, if they need a fuse, chances are they're going to have an automotive style fuse laying around to replace it rather than a small glass fuse. I also like these small fuse blocks because if you can see in the center there, these LEDs, let me pop this cover off. These little red LEDs in the center are like tattletales. You could think of them like that. So pretty much when a fuse blows, the LED is wired in parallel with the fuse. So the fault current that opened the fuse element tries to pass through the LED, and since the LED can only pass so much current, it lights up. It's not enough current to actually power the device and fault the system out, just enough to light that LED and let you know that the fuse is blown. So this all has to get labeled, and pretty much what I have to do today. I'm not going to actually show wiring all this because it's going to be a little bit boring. Doing this kind of stuff is a bit tedious, but once it's all done, I'll bring you back. We'll get the control panel programmed, and we'll be ready to fire it up. So we're making a little bit of progress here. Got the wiring for the main control relays here done. Looks pretty good. Got everything labeled there. Yeah, if you do this kind of work, it's really really nice to have these label makers. I use this one here. These are pretty inexpensive. I think this costs like $45, maybe even less. You can print these nice wire labels. So that's done, and I have the control harness that's going to run from the controller down to these operator relays. But let's give these a try first. So the reason I chose this particular style of relay is because they have this the feature where you can activate them externally. These little blue buttons here will actually pick the contacts up. And then if you flip this little tab up, it will pick the contacts up and hold them there. So R1, R2, and R3. R1 is our preheat, R2 is crank, and R3 is run. So let's try the preheat. We're going to go ahead and flip that tab up. You can hear the contactor pick up over there, and we should see, there we go, we're starting to glow there. So now I'm going to push this little button here, the little blue button. Oh, we already got some fire there. Okay, a little bit of extra fuel there. I'm going to crank it. Okay, let me turn that off. So I've got to wait till that cools off, and it should stop spewing fire. Okay, that's good. So yeah, R2, I can press that and crank the engine over. R3, let me come over here, is going to be the run circuit. Let me flip that up. And where's it at? There we go. Picked up the fuel solenoid. And if I pick up the fuel solenoid and crank, you'll see the governor move. Yep. So that all seems to function just fine. All right, well, let me proceed with this. Well, here we are, all completed. Controller's powered up. We're not in automatic. I did have the gen set running earlier, so the temp is a little up there. Battery voltage, oil pressure 0, obviously. Fuel level says NA. If we had a fuel level sender for a tank, that would give us a percentage reading of the fuel tank capacity. We got our 2 control switches. One is the control power, the other one is the preheat. So if we wanted to have the gen set, the little intake heater operate on startup, we would just flip that to on. Here's our control panel on the interior. Came out pretty nice. Got our fuses labeled there. And on the inside I have labels for what their function is. I'm pretty happy with the way this control panel came out. I was a little bit worried that this box wouldn't be large enough, but turns out that it is. This third switch here that's not labeled is just a spare at this point. Alright, well, I think you've about seen enough of the gen set. Let's take a look at the programming of this controller. We'll do a quick overview. We'll open up the software on the tablet over there, and we'll go through the basics, the extreme basics of programming these things. You can also do most of the programming through the front panel, which we'll scroll through the menu here. So we got metering. You would go to settings. Oop, wrong button. So we got general settings, communication, system parameters, inputs and outputs. So you can do most all the programming through here. Now the logic is a different story. You wouldn't want to try to do that through here, if you even could. I've never tried. Let's see, what's system parameters? System settings. Gen connection is delta, rated kilowatt 45, rated volt 240, all that stuff. So we can do whatever we need through here. It just takes a little bit more time. The metering, we got engine metering, oil pressure, engine load 0%. You can set maintenance timers. There's our total runtime. I usually get that from run statistics, cumulative, and you can see the total runtime loaded or unloaded. I usually just look at total. 1745 hours and 8 minutes. All right, well, let's go take a look at the software. Okay, this is the Basler Best Comms Plus software. This is what you use if you want to program a Basler control panel or a voltage regulator or other device. So when you open it up, well, when you connect to the controller, this is the screen that pops up. The top section is the Metering Explorer. This lower section is the Settings Explorer. I'll show you the Metering Explorer real quick. I'll just move this down. So you got some general stats on the generator over here, what mode it's in. You can control the generator remotely at this point by selecting whatever function you want it to be in. And then over here, you can expand the menu and see device info, just general stuff about the unit, engine stats, oil pressure, current temperature, battery voltage, current speed, all that stuff, total engine run hours, generator statistics. We're not generating anything at the moment. All that good stuff. And then you have the status of the various inputs on the controller and the outputs. So this really isn't going to be a full overview on this software. The software is so comprehensive that, you know, a little clip in this video is not going to do it justice. But I'm going to go through and show you how simple it is to get one of these things set up. So let's go to the Settings Explorer. General settings, got front panel, bunch of different values here. I usually keep the sleep mode disabled so that the display and the panel lights are always lit. You can select English as your language or whatever. And then I usually set the phase toggle delay at 5 seconds, which that scrolls the display through the different phases A, B, and C for the display for current and voltage. Enough of that. Oh, you can set the clock up and everything like that. So again, this software is pretty comprehensive. System parameters, that's another important one. System settings. System, single generator. Fuel level setup. This control panel can monitor a fuel tank for level. The NFPA level, which in this case it's 0, that refers to the regulations the generator would fall under. Level 0 is pretty much unregulated. Level 1, I believe it's worded as loss of life likely if the generator does not operate correctly. Level 2 is less a chance of loss of life if the generator does not operate. So pretty much anything in a hospital or a medical care center is going to be level 1. Level 2 would be anything like a pump station for a sewer plant, or maybe backup generator for a manufacturing facility, as long as there was no life safety equipment on it like exit signs and egress lighting. Let's see. System units English, or for our Imperial. And speed signal source, gen frequency. It can also be mag pickup frequency. We're using gen frequency. I usually set them to use gen frequency just so you don't have to have a second mag pickup for the controller. Rated data, also another important one. So generator potential transformers, PTs, bus potential transformers, we're not using any of those. So our primary and our secondary voltage is just the same. Generator CT for current sensing. We got 5 amp CTs. The primary amperage is 200. Rated voltage line to line, all that good stuff. And then our battery voltage, 12 volt or 24 volt. This is all grayed out. You have to hit this little button to edit it. Generator frequency, rated frequency 60 hertz. Alternate, we don't have to worry about that. Miscellaneous generator connection is delta. We are running 12240 delta. Bus connection single phase. That really doesn't matter. I could set that to 3 phase. Phase rotation ABC for clockwise. Remote module will not have any of them. Let's see. Crank settings. Here you go. Pre-crank delay 5 second. That is for the preheat, which we'll see in a little bit. Cranking, cycle cranking. So cycle cranking means it will attempt to start the engine 3 times. It will crank for a total of 10 seconds each time and will rest 5 seconds between each crank attempt. Crank disconnect speed is 50% of rated. So once the engine hits 900 RPM, the starter will disengage. I have the oil pressure crank disconnect disabled. I had some issues with that. If the unit was cranking, but it was cold and it wasn't wanting to start, the oil pressure would build up past the threshold and it would just stop cranking. Cool down mode, that's disabled. We're not using that. Let's see, automatic restart, exercise timer, sensing transformers, relay control. We'll go into that. The control panel has 3 high current relays: the start relay, the run relay, and the pre-start relay. I have these set as predefined. Pretty much the controller knows what to do with them. It knows when to activate the start relay and the run relay. The pre-start I have is programmable. We'll get into that when we see the logic. Let's see. What's next? Programmable inputs. We got a couple of those. Let's see. We don't need that. We'll just skip over that for right now. Outputs. Alarm configuration. That's the next important one. Horn configuration, which is the audible alarm. We have it enabled, and we have it enabled when the controller is not in auto. Pre-alarms for the gen set, or for the engine, really. Let's see. Low oil pressure. We have that pre-alarm set at 25 pounds. Weak battery voltage is enabled at 8 volts after 10-second delay. So if, for example, if the unit is cranking and while cranking that battery voltage drops to 8 volts for 10 seconds, it'll trip a weak battery. Low battery voltage is set at 10 volts. Activate after 10 seconds. Low coolant temp is disabled. I could enable that. We'll go into why that's not enabled in a minute. High coolant temp is enabled. move over a little bit here. So pre-alarm for high coolant temp is set at 200 degrees. If the unit hits 200 degrees, the alarm will sound. The unit will keep running though. High battery voltage, 15 volts, in case the alternator starts overcharging. Let's see, what else? And overload, engine kilowatt overload is 105%. So if our load exceeds 105% of the unit's rating, we'll trip pre-alarm. Let's see, alarms. Alarms is pretty simple. High coolant temp. It'll shut the genset down if the coolant temp hits 210. Low oil pressure. It will shut the engine down if we hit 20 pounds of oil pressure. Overspeed. If the unit exceeds rated speed or 100% speed by 22%, it will shut the genset down after half a second. Low coolant level is disabled. CAN bus low coolant level. Well, this is in a non-electronic engine, so we have no CAN bus. And sender fail. I don't know if I've set this one yet. Let's see. So, if our coolant temp sensor fails or oil pressure sensor fails, it will go into pre-alarm. Yeah, I did set that. It will not shut the genset down, but it will let you know that it's no longer able to detect oil pressure or water temp. Generator protection. Voltage. We got under voltage, over voltage. Now you see we got 2 under voltage and 2 over voltage. This is typically used, you use the second under voltage. If you had a multi-voltage unit, you would have an under voltage and an over voltage setting for either its high voltage connection or its low voltage connection. Same thing for frequency, current, power, reverse power. We always enable that. That's just in case, for whatever reason, while the genset's running, something starts backfeeding it, it'll shut the engine down. Breaker management we don't have to worry about. Multi-gen management we don't have to worry about. Programmable senders. So there are multiple coolant temperature sensors available for these gensets, as well as oil pressure. And let's see. So you can see there's a couple of coolant temp sensors. So you got a DATCON. Let's see, an ISPRO, Stewart Warner, a couple different pre-programmed ones, but you can also load different resistance curve files. So you can see here's a display of the coolant temperature versus the resistance of the sensor. It's a whole other thing to go into. And then finally the logic. Let me close out some of these tabs here. The logic on this genset or on this controller is extremely basic. Hopefully you can tell that what I'm doing with this controller is pretty much the bare minimum of what it can actually do. These things can be programmed for so much more than what you're seeing here. So here is our logic diagram. It's very, very simple. Our input 16 triggers the ATS function of the controller. That pretty much is the remote start input. So when input 16 is pulled to ground, the genset starts up and runs. When we shift the genset into run mode, well, it would obviously run. We don't typically need this status input here, but I do need it for the pre-start function. And then there's input 15, and then we got one contact output or status input. So when the audible horn, AUD horn, whenever the controller wants to trip or activate the warning siren, the audible alarm, it picks up output 1, which I have labeled as audible alarm, and that powers the little buzzer up at the front of the panel. So really the only piece of logic here is the preheat enable or disable, which is that second toggle switch on the front panel. So let's go to the simulator. Click that. There we go. So let's say we want the preheat to operate. So the thing's not on a block heater, it's cold. If it receives a start signal, we want the little preheater to come on in the intake manifold. So you would flip that toggle switch on, which would activate input 15, so we can activate that. And then in that case, if we enter a run mode for whatever reason, that activates the preheat. Same thing with input 16, which is a remote start. See, it lights this up and gives our pre-start out, so it activates that heater. So now if we turn input 15 off and hit run mode, we don't get a pre-start, we just enter run mode. Same thing with input 16. I'm just double clicking on these to activate them. See, we don't get our pre-start, we just start the genset up remotely. So that's extremely basic. I'd like to refine this a little bit. I'd like to be able to remove that 5-second time delay on crank when we are not using the pre-start. That's a whole other thing I got to go into, but this works fine for now. So that's pretty much it. Let's see, turn that off. All right, well, that was an extremely basic overview of what you can do with these controllers. But I really like these. They're really easy to work with. So I think at this point, we're ready to haul this thing outside, hook the load bank up, and do our commissioning load bank, 4 hours at 100%. So let's get to it. We moved this operation out to the side of the garage here, just to kind of keep the noise away from the neighbor's house a little bit. Got the load bank hooked up. Let's turn the controller on. Okay, so we just had her running. Temperature's already up. The sun might be kind of washing this out a little bit, but we're ready to go. 100% load there. So, now we wait 4 hours. If she can run for 4 hours at 100% load, I'll be satisfied. I think it'll do it no problem. Well, we've been going for a little over 4 hours at this point. About 100% load. Seems pretty good. Alright, well, we just shut down after a little cool down time. So, I'm pretty pleased with it. Now, the 4-hour test did reveal 2 issues, and they're fuel related. Seems I can't ever win with this fuel system. I've got some fuel seeping around, I believe, this sealing washer here, and maybe this one here on the high pressure discharge tubes. I don't know. These are snug. These washers are new. I even replaced the these actual tubes themselves because I had issues with the line nuts sealing. So I might try to go with a copper sealing washer rather than these steel ones that they give you. So that's issue number 1. Issue number 2 is number 4 injector. Can you see down there? There's a little fuel sitting right where the injector body meets the cylinder head. See that? And I noticed that seeping down along the head here. So that's pretty annoying, considering I took those to the shop to have them repaired. So that one's gonna have to come back out and get sent back to the shop and see why it's seeping fuel. Other than that, it ran great, and it's ready to be sold. Of course, after those 2 issues are corrected. So it can pretty much put this project to bed. I mean, it's had a control upgrade, a new voltage regulator, new governor. Obviously it had an oil change and all the filters, coolant flush, new coolant in it. Yeah, it's about ready to go. So, and it was a long process getting it done, but I'm pleased with it. Well, thanks for sticking with the project, and I'll see you on the next one.